In this experiment, we'll be looking at how to predict the products of and write the balanced equations for reactions based on the reactants used and analysis of the products produced. Because many reactions produce gases, we'll first look at positive tests for a variety of different gases that may be produced. One of the possibly produced gases is hydrogen gas. Hydrogen gas is identified when fire causes a loud pop from a small explosion. Another possible gas is oxygen. Oxygen supports combustion and will cause a fire to burn more strongly. Gaseous ammonia is a gas that is easily detected by its strong odor. Carbon dioxide is a gas that inhibits combustion and will therefore extinguish a fire when placed inside it. And water vapor. Water vapor will condense into liquid water when it comes in contact with a cool surface. In the first experiment, we will burn magnesium to react it with oxygen. Here's the equipment that will be used in this experiment. The Bunsen burner is turned on. The magnesium is held in the crucible tongs and then exposed to the Bunsen burner flame. It is allowed to burn over the watch glass completely. Notice that the magnesium has turned into a white, flaky powder. In the second experiment, magnesium will be reacted with hydrochloric acid. Here's the equipment that will be used in this experiment. A wood splint will be used to test the products of this reaction. We will also use a gas collection tube in order to collect the gases to be tested at the end of the experiment. We'll be using an inverted test tube to accomplish this. Five milliliters of hydrochloric acid is measured out and then added to the test tube. A piece of magnesium a few inches long is then taken and cut into several pieces. These pieces are then also added to the test tube to start the reaction. The test tube is placed under the gas collection tube to collect the gaseous product produced by this reaction. We then test the gas. In the next reaction, we'll heat ammonium carbonate. Here's the equipment that will be used. This experiment, just like the last one, also requires gas collection. A small amount of ammonium carbonate is transferred into the test tube suspended above a Bunsen burner. The Bunsen burner is then positioned beneath the ammonium carbonate test tube. The gas is turned on, and the Bunsen burner is lit. The gas collection tube is lowered to cover over the mouth of the ammonium carbonate test tube. The gas is then tested. In addition to this, a strong odor is detected. Our fourth experiment will be a reaction between 1 molar solutions of copper 2 sulfate and sodium phosphate. Here are the solutions and the test tube that the reaction will be performed in. Notice that the sodium phosphate solution on the left is a clear color. Meanwhile, on the right-hand side, the copper 2 sulfate solution is blue, yet it is still transparent. Securing our test tube, we'll add about 20 drops of the sodium phosphate solution to the test tube. Afterwards, we will add 5 drops of the copper 2 sulfate solution to the same test tube. Already we can see that the solution is much more cloudy. However, this change is much more apparent once we add some deionized water to it. In the final experiment, we will be adding a magnesium dioxide catalyst to hydrogen peroxide solution. A catalyst is a substance that speeds up a reaction, but is not actually consumed in the process. Approximately 5 milliliters of hydrogen peroxide solution is measured out and then added to the test tube. A very small amount of the manganese dioxide catalyst is then added to the test tube. We hold a lit splint to the gas coming out to test it. As the experiment concludes, we notice that there's still a slight amount of bubbling, and the manganese dioxide catalyst remains sitting at the bottom of the test tube, unreacted.